Hello, in this tutorial, I'll be showing you how to use LcMsSpectator to look at a single top-down spectrum. To start, open the software and click on the Open Raw MZML file button, and this will open the window for you to select the raw data. And the LcMsSpectator is compatible with the Thermo raw data. You can directly open it. You won't see anything right away because you have to select the scan number, which is the single scan number 1. And this will show you the raw data. This is the native top-down spectrum of the alcohol dehydrogenase protein, tetramer protein. This was a UVPD spectrum. To be able to match to the fragments automatically without deconvolution, you just need to put the protein sequences here, and already have some saved sequences for the ADH plus the modification at the end terminus, which is acetylation, labeled by the numbers shown here. So if you copy it here, and you have to set up a charge, which is restricting the maximum charge you will look for among the fragments. Typically, you would set it to a number that's the same as the precursor, just to make sure you don't miss any of the ions. In this case, I'll just simply set a like 20 for now. And after you click on View Target, and it will start to match all the fragments. As you can see, it will start to populate the coverage map and report the sequence coverage here. You'll notice that we're only matching B and Y ions here. That's the default if you have HCD data. But if you need to add more ion types, right-click and select the ion types. We know in UVPD we have other ion types, so I just select some of them. And this is really your own choice of which ions you are going after. And I just select a few representative ones. And now you'll see you're matching to a lot more ions as they're slowly being populated up here. To better display this crowded region of all the fragments, you can use your middle mouse button and scroll it. And this will zoom the axis if you leave your mouse at on the x-axis. The same goes for the y-axis. The display function is identical to the tutorial previously put on YouTube, which is for the LCMS data. The difference for the single spectrum data is that you don't have the LC dimension, so you don't have the corresponding MS1 data. We can actually hide this by clicking this. And again, because we don't have LC dimension, the XIC view and feature map won't work. So we are just focusing on this spectrum view. For the zoom in and zoom out function, it's the same as the LCMS data. Just want to show it again. You can actually also click on the Show Manual Adjustment button. And this will allow you to manually type in the region you want to zoom in. And this can be very helpful if you're trying to make this for publication or for consistency. The y-axis by default is automatically zooming in the maximum peak in this view window. If you want to change that, uncheck this automatically adjust y-axis button. And if you have the manual adjustment checked, it will also give you the window you can type in the numbers you want to zoom in. Like say if I want to highlight the smaller ions, oops, like this. So you will zoom in to the smaller ions, you can better display them this way. The same thing works if you use your middle mouse button to scroll. And you will actually be able to zoom in as you wish. And if you right click and drag, you will be able to pan through the views. Yeah, so this is the same as your LCMS data. There are also other functions you can use, which can be helpful. For example, the noise filter mode. If you're worrying about matching too many noise peaks, you can select some of them. And some of the other peaks I talked about before. A few things I want to mention here is the show top end peaks. So by default, it will only display the top 5,000 peaks. If you need to show more, you have to manually select that, but it will also slow down the display. Ion types I've mentioned, you can also turn on neutral loss peaks. So there are hydrogen, water loss and ammonia loss by default. And you can save this as an image, or you can save the pick list, or you can copy the pick list to clipboard. And if you click on this view and press Ctrl+C, you also copy the view as an image in the clipboard. In the sequence view, you will report the sequence coverage, and you can export as an image if you want to use it for publication. And the other thing I want to mention here is the error map, which can be also very useful. So if you click on this, there will be a new floating window showing the error map. Basically, the error, ppm error of each fragment, each matched fragment across the whole sequence of the protein. And the color scale is shown here. So by default, all charge states are combined. So you only see one row for each ion type. And if you uncheck this, it will give you all different charge states. You'll see if you have a good match, you will expect everything lies in a very nice slope. In this window, you also get a table of all the matched fragments, and you have all the detailed information on those fragment ions. And this can be exported as well. You can copy as a table, just select everything and copy it out. And you should get the same thing if you're using the save pick list function. So on the top, it does show you the basic information on the precursor ion mass, charge state, and also your PTM. And if you want to play with the PTM assignment, you can actually change it. For example, if you want to remove the acetylation and try to match it again, and now you are not matching a lot of the ions because there is missing mass at the N terminus. One thing to note that sometimes, like when you change this, it will reset the ion types. So you have to select it again to view the ion types you're looking for. So that's the basic function of viewing the single spectrum data. So I'll close this for now. And just to show you, you can also do this for other types of mass spec data, the data from other vendors. Although you don't have direct native support for the other instrument vendors data, you can convert it to the generic MZML, or I usually use MGF for this type of data. Example I'll show you here is some Waters CNET top-down data for hemoglobin alpha subunit. So what I did was to convert the raw data in mass links into a mass table. So this is pretty easily done if you have any kind of vendor software. So you do some peak picking. Usually you have to centroid the data because the LcMsSpectator does need to take the centroid data. So you can do the centroid or automatic peak detection in the vendor software, and you can find that based on the tutorial of your vendor software. After that, I create an MGF file. So you just need to have some basic header, begin ions, and then you have to end with end ions. And then in the middle is basically mass to charge and peak intensity. So this is a format that LcMsSpectator will directly take. I haven't explored other formats, but this works pretty well. And you can easily create those with instrument vendor software for any kind of mass spec data. So if you have the MGF file, so just the same thing, open raw data. And it does have all the other format it supports. You can try it out and see how it works. But I found the best is to use MGF because sometimes you have to sum across multiple scans to improve your signal noise in the raw data. So you can have all the native support from the vendor software to do whatever data processing you want and some filtering you want or smoothing, and then have your centroid data in the MGF format. So you open it, everything will be the same. So if you click on this, you will see the centroid data for the top-down of hemoglobin alpha subunit. The same thing, I already saved some the protein sequences here, you can put in here, put in a charge state, say just arbitrarily take 10 plus charge state, click on view target, and then you start to match the fragment ions. So this works to any kind of data you can put into MJF format. The last thing I want to mention briefly is like sometimes for some of the instrumentation, you may not have very high mass accuracy. In that case, you may want to open up your mass tolerance window. So by default, the ppm error is 10, plus and minus 10. So to change that tolerance, you go to the config settings. And this is where you set a precursor line tolerance, which doesn't apply here because we are only looking at MSMS data. So you can change this to like say 20 ppm for product ions. And a few other things like for the Pearson correlation for isotope fitting, by default is 0.7. So if you need to lower the threshold, you can change this number. So there are also other things you can play with, but for now, those are the things that are more important. So if we click on this, yeah, you will see like some of the ions may be having higher mass error and fall out of the 10 ppm mass range, and now you will be able to see it being matched. Again, everything else works the same way. You can view the error map and any other functions that I mentioned previously. Yeah, that's the tutorial for looking at the single spectrum top-down data. Hope you enjoyed it and helpful for your research. Thank you for watching.